All right, we're looking at correlation here, which is the relationship between two variables, or the strength of the relationship between two variables. We have the number of hours studied and the test results as a percentage. So this person here studied for 20 hours and got 27%. We want to find out if there's any relationship between the two. Therefore, if you study more, do you get a higher result? So I've entered all this data into the graphic calculator. List 1 is the study hours, list 2 is the test percentage, and now we want to draw a graph. We want to draw a scatter plot. So we've got to go to set, which is F6, make sure our graph type is scatter, and we have list 1 and list 2 in there. So that's going to draw it for us. We then want to go and select to make sure we are drawing a graph. Yep, that's pretty cool. It says stat graph 1 draw on, that's what we want. And if we go to draw, which is F6, it will draw the scatter plot for us. And you can see that we have got a trend going this way, which indicates the more you study, the higher your results are going to be, but we've got a couple of outliers flying around here as well. We can draw in the line of best fit and find the correlation. So you go to Calc, then F2, which is X, and it gives you the R and R squared. So R squared is Pearson's correlation, or the Pearson's correlation coefficient is this, and R squared is this, which then therefore means that it's a very weak correlation because it's 0.3. We can also draw the equation of the line from there. Now, we'll just make sure, we'll just draw it again. And now what we'll do is we'll get rid of these outliers. So we want to know what that piece of data is and that piece of data is. Okay, and then we're going to see if our correlation is stronger. Remembering it started off as 0.3. So if we go Shift, Trace, and then move the arrow key around, we can actually move around through the pieces of data until we find the ones that are outliers. There's one there, and it's 15 and 55. And then this one here is 23 and 1. So 15, 55, 23, 1. So you get out of that, and you go through until you find 15, 55. There it is there. Delete, and make sure we go across and delete that one there. And I reckon the other one was 23 and 1. Let's see, whoop, there it is there. So delete it from that column and then come across and delete it from that column. So the pairs stay the same on the way through. Now what we can do is make sure we've still got there. We can draw it, and you can see it's a far better correlation with those outliers. We can then calculate to see how strong that correlation is, which is F2. And we've now got 0.96, which is a very strong correlation. So what it means is that this has now gone from a weak correlation to a strong correlation once we've taken out those two outliers. Now it may be valid not to take them out, because someone might just do very little homework and get a really good result, or do a lot of homework and have no idea what's going on. So you have to have a look at the data and what it's telling you to make sure you can pull it out. If you're going to write the equation of the line, remembering it takes the form y equals ax plus b, our a value is 1.08 and b is 4.57. So it would be y equals 1.08x plus 4.57. And then you can do predictions. You can do your predictions from that using the equation of the line. Very good.